Hello everyone. Let's see this question. Two particles A and B are moving towards each other on a straight line with equal speeds 5 meter per second. At an instant that is assumed t equal to 0 second, distance between particles is 100 meter. So initially the distance between A and B is 100 meter. This distance is 100 meter. Now they are moving towards each other with 5 meter per second. So when can this happen? That there can be a third particle C which maintains a distance of 40 from A and 30 from B. So if it is maintaining a distance of 40 from A and 30 from B, the maximum separation between A and B that you can have is 70 meters, right? And this separation will happen at what time? It will happen at t equal to 3 seconds, right? At t equal to 3 seconds, the separation between A and B will be 70 meter and you will have C in between them. Now, as they continue to move towards each other, the separation keeps on reducing. Now, the minimum separation that you can have, because from one you have to have separation 40 and from the other 30 meter. So, the minimum separation that you can have is only 10 meter. So, 10 meter separation, when would we have? So, this is 70 meter right now. This is moving with 5. This is also moving with 5. So, you can say relative speed is equal to 10. So the separation between them will become 10 after 6 more seconds, right? So right now it is 70. 60 meter more distance will be covered by both of them combined after a time of 6 seconds. So that means till 9 seconds. So from 3 till 9 seconds, the separation between them will be in the desired range. And after that, what will happen? After that, the separation goes below the desired range. So at some point, A and B will cross each other. You cannot have C in that situation because it will not be able to maintain 40 from A and 30 from B. Now, once again, C can come into picture when they have crossed each other, and now the separation between them again, so B is here and A is here. Now the separation between them again is 10 meter. So this will happen when? This will happen once they have met and then crossed each other, and now the separation between them should be 10 meters. So you can imagine this in the frame of A. Let's say B comes. B is right now at 70. So in the frame of A, B is coming, and this is t equal to 3 seconds, and B is coming with a speed of 10 meter per second, right? So when it will cross on the other side and the separation will become 10 meter again, that will require how much time? It will require 8 seconds, right? So 8 seconds after this beginning of this thing. So that is 8 seconds after 3 seconds. So that means what? From 11 second again, this condition will start getting satisfied. So you should have that time is greater than 11 second. And then what should it be lesser than? So now when they cross each other, so once again in the frame of any one of them, you can move the other. So it will keep on moving and C can be there somewhere in between them till the time B takes to go from here by 60 meter, and that will require 6 more seconds. So you can say till 17 seconds. So what should be the answer? Our answer should be A and C. Then next question is, what is the speed of particle C at the instant t equal to 5 seconds? So at the instant t equal to 5 seconds, let's draw the situation. At t equal to 5 seconds, what would have happened? Initial separation is 100. So t equal to 5 seconds, this would have moved by 25. On the other side, this also would have moved by 25. So both are moving with a velocity of 5 meter per second. And from A, the separation should be 40, and from B, the separation should be 30, right? So this is the situation. So C would be here, we have A here, and we have B here. So in this situation, you can see that this length will be what? This length will be 50. and that gives us a right angle triangle, right? 40 square plus 30 square is equal to 50 square. So it gives us a right angle triangle. So we understand that this angle is 90 degrees. So we have to find the speed of particle C. Now the speed of particle C, let's take along this direction, it is Vx, and along this direction, it is Vy. So it will actually be opposite of that. So let me take Vx this way and Vy this way. Okay. So these are the components of velocity of C. Now what should happen? We can use velocity of approach and separation. This separation between these two has to remain 40 only. So for that to happen, the velocity of approach from this side should be equal to the velocity of separation, that is Vy. So we can say that if we take this angle to be theta, we can say that this 5 cos theta should be equal to Vy, and from the other side, if this is theta, the other one will be 90 minus theta. So we can say that 5 sin theta should be Vx, and hence V should be what? Square root of Vx square plus Vy square, which gives us how much? 5 meter per second. So that's our answer. Next question is, what is the modulus of acceleration of the particle C at the instant t equal to 5 seconds? So at t equal to 5 seconds, you can imagine this, that the particle C is undergoing, you can say, two circular motions. So one circular motion is about A, and the other circular motion is about B, right? So it is undergoing circular motion about these two. Why? Because the distances from these two are constant. Okay, so the distances from these two are constant. So it is moving, you can say, with respect to this as well as with respect to this, it is moving in a circular motion. So now what should happen? Now we can take that with respect to this, if it is moving in circular motion, then its velocity, its acceleration along this direction would be how much? It would be omega square r1, and its acceleration along this direction would be how much? It would be omega square r2. And these are the two mutually perpendicular components of acceleration, and that must give us the net acceleration. The vector sum of these two must give us the net acceleration, because the net acceleration must be in this plane only. So how much would be omega? So omega is what? Omega is equal to V relative divided by R. Okay, so we can have different omegas. So let's say this is omega 1, this is omega 2. So omega 1 would be how much? Omega 1. So omega 1, V relative perpendicular we have to take. So omega 1 will be Vx plus 5 sin theta divided by R. R is how much? 40. Now how much is Vx? Vx is also 5 sin theta only. So what do we get? We get 10 sin theta by 40. So sin theta by 4. That is omega 1. Similarly, how much is omega 2? Omega 2 would be circular motion in the frame of this particle. So in the frame of this particle, the omega 2 would be how much? It would be 5 cos theta this time. 5 cos theta plus Vy, right? Plus Vy, and Vy is how much? Vy is also 5 cos theta divided by what? Divided by 30. So what do we get? We get cos theta by 3. This is omega 2. And hence the net acceleration will be how much? It will be omega 1 square r1 plus omega 2 square r2 root over. So omega 1 is sin theta by 4. Now theta we can calculate here, right? So we can see that this is 3 and this is 4. So that means what? Theta is 37 degree. So sin 37 degree is how much? It is 3 by 5. So what we would get? we would get 3 by 20. And cos 37 degrees what? It is 4 by 5. So we would get what? We would get 4 by 15. So these are the omegas. Now let's put it here. So we'll have what? 3 by 20 whole square into R1. R1 is 40 plus 4 by 15 whole square into R2. R2 is what? 30. So what do we get? We get 9 by 400 into 40. Okay, and here we get what? Here we get 30, no, we get 16 divided by, let's put it 15 into 15 only, 15 into 15 into 30. So that gives us what? That gives us this value. We'll have what? Here 4, 10. So that is 0.9, right? Plus 32 by 15. So 32 by 15 is what? It is 2 point something, no? 2 by 15, yeah, 2 point something, 2.1 around, maybe that. So square of that, right? So we'll have to put square everywhere here. So how much would we get? 0.9 square plus around 2.1, 2.2 whole square. So we would have 0.81 plus 4.41, which is around how much? It is around 5.22 root over, right? 5.22 root over, which would be around this value, right? It would be around this value. 2.3 square would be near about this. Yeah, so that is our answer. Next, another option is, at the instant when the line joining the locations of A and B is perpendicular to the line joining the locations of B and C, A and B, A and B, and B and C. Line joining the locations of A and B is perpendicular to the line joining the locations of B and C. Let's draw that. So we have A here, B here, and we have C over here. A and B is perpendicular to the line joining the location of B and C. What are the magnitude of velocities of C relative to A and B respectively? Relative velocity we are being asked. So we know that this is going with what? 5, and this is also going with 5. And velocity of separation for this A and C or B and C pair, that must be 0. So this angle, if it is theta, what should happen? Here C's velocity, when this is perpendicular, now it cannot have a velocity along this line, right? Because if it has any velocity along this line, the separation is going to change, but separation must not change. And the only possibility then is that velocity of C must be like this. So velocity of C is like this. Now it is making an angle theta, and now the separation with A cannot change. So that means what? That means VC must be equal to 5. So VC is equal to 5. So then relative velocity with respect to A is how much? With respect to A, it will be 0, because both are moving in same direction with same velocity. And with respect to B, it will be 10, because both are moving in opposite direction. So that's our answer.